Well, good morning, everyone. It is a real pleasure to be able to engage with you in this, our first webcast regarding this new product of HostBridge that we call HTAC. This, like many of our products, really sprung out of specific customer feedback and input, and we've learned a lot over those last 4 decades about what customers are looking for, and quite a bit even over the last year. And many of our customer interactions over the past year have led us to develop this, what I would call a targeted strike technology. This technology with HTAC solves a very specific problem that we believe in many organizations will allow them to extract a lot of value. So let me go ahead and begin the slide presentation. Many of you probably may know of HostBridge. Some of you I know are customers. I won't belabor this introduction to HostBridge, but we have been around quite some time. HostBridge specifically was founded in 2000. One of the things that we like to do as a company is we are integration people. We are the civil engineers, if you would, in the mainframe world. And we are constantly, over that last 40 years, looking for ways to build high-value bridges between whatever is new, mobile, and modern outside the mainframe world and whatever is the state-of-the-art inside the mainframe world as well. We come at this with certain biases. One of them is that we are obsessed with performance. Secondly, we like to exploit what's in the box. In other words, if you're already paying IBM to do something, I really don't think you're going to be paying me to do the same thing or any other ISV. So we ought to exploit what's in the box, and this product, HTAC, is an excellent example of that. We also, because of our integration roots, believe that industry standards are very important, whether that meant XML a decade ago or JSON today or server-side JavaScript. We focus on those industry standards. And then specifically, we really do, what brings all of us as a team a lot of pleasure is if we can innovate and do hard things. That's what really gets me up in the morning, and I think what drives HostBridge as a company. Okay, so that's HostBridge in brief. We do have a very nice customer base. We're very proud of them. I won't belabor this point, but it seems like it's always obligatory to at least do a little bit of a logo splash and let you know that we are a known quantity in the community, and our customers are usually very happy to hear from other prospects or customers to ask questions as references. So what is HTAC? We call it the Transaction Analytics Connector, and who it is for are enterprises with mobile, web, or cloud applications that are supported by CICS on the back end. Very specifically, HTAC in its current version is all about integrating in a new way mobile, web, and cloud-based applications with CICS on the back end. Now, what HTAC does specifically is it allows these so-called SIEM platforms to capture end-to-end analytic data. Let me define that term. SIEM is an acronym, I think first coined by the Gartner Group. It's essentially Security, Information, and Event Management Platforms, SIEM. Now, in reality, some people do use these platforms for security-focused things, some for event-oriented things, but this whole genre of products, whether they be Splunk or any other product, they excel at being able to capture large amounts of analytic data and then do something with it to yield new knowledge or information. So what HTAC does is allows these SIEM platforms such as Splunk, which we'll demonstrate in a moment, to capture end-to-end analytic data from the point of origin all the way through CICS transactions. Another way to say it is that what HTAC is trying to do is address a visibility gap. If you go into, for example, I was sitting at a customer site a few months ago and I asked them if they use Splunk, and they said, well, yes, we do. And I said, okay, what can you see using Splunk? And they said, oh, wow, we can see everything. We can see the client side. We can see what's going on there. We can see the network side. We have great visibility. And I said, well, what about the mainframe? They said, well, not the mainframe. We can't see anything. Once the request goes into the mainframe, it kind of goes off the radar screen, but then once the response comes back, then it's back on the Splunk radar screen. And of course, when I asked the question, wouldn't you like to solve that? Because that's really what we do. We put CICS transactions on the SIEM radar screen. It's a targeted strike to do just that. Now, you're going to hear me talk about both Splunk and CICS, and on a call like this, it's not uncommon to have people who are maybe more well-versed on Splunk and less on CICS, and some who are more on CICS and less on Splunk. So I won't belabor the point here too much, but I do just want to make sure if you're a mainframe person and you're not familiar with Splunk, which we'll be using, they are the industry leader in this range of products called the SIEM Product Platform Group. So it's a software platform for searching, monitoring, analyzing machine-generated big data. It has a really nice web-style interface, and we'll look at it in a minute. Splunk can capture and index and correlate all sorts of data. It can create all sorts of visualizations, generate graphs and reports, and like I said, it's becoming, in many of our customers, this is what they use. They have a significant number of customers worldwide, but this whole idea of bringing Splunk and the mainframe, and specifically CICS, together is fairly new in the Splunk community. If you know Splunk and you're new to CICS, let me just define CICS as being, probably the best way is to say it's a family of mixed language application servers that provide high-value online transaction processing on IBM Z Systems mainframes. A CICS transaction, we're going to use that word, transaction, is simply a unit of processing initiated by a single request. But transactions can start other transactions, and so you can have this chain of events that occur inside the mainframe. CICS manages the entire transaction such that if the transaction fails, everything's recoverable and all is well. So with just that ever so skinny introduction to both Splunk and CICS, let's kind of dive in a little further. First of all, this diagram for me helps to really describe the need for HTAC. We live in a world where whether we're sitting in blue chairs or on airplanes or running around half crazy some days, we are carrying devices, whether they're cell phones, tablets, laptops, whatever, and we are in constant contact with various cloud, mobile, or distributed apps. And that's really the landscape in which Splunk as a SIEM product really grew up in. It was instrumenting, orchestrating, managing all of that data and all of those interactions between the networking equipment, the end user, the ultimate services on the app servers. And if you don't have a mainframe, or in other words, if there's nothing to the right of that server cloud, then life is good. You have complete end-to-end visibility. But what if you really have a mainframe back there, and a mainframe is teeing up some of your critical business data and or application logic? What happens then? Well, really, that's, like we said, you kind of hit a dead end. You have partial visibility, but on the SIEM dashboard, you might see the request coming in. It's being processed. You might see the request going out to the mainframe. Then you see nothing about what's going on inside the mainframe until you get a response, and yes, it came back and all is good. But still, the mainframe and the things that happen inside of CICS really weren't part of the SIEM analytics and the dashboard. And so that's really what we're trying to solve. Again, with a targeted strike, just to solve that problem so that you can have full visibility all the way from the end user with a modern mobile device all the way through the back-end CICS transactions that are fulfilling those, many times, those service requests. Now, let's kind of get down a little more technical here. I mentioned that we're a big fan of using what's in the box. And one of the things that comes in the box now is CICS Transaction Tracking. And for those of you who are CICS professionals on the call, you will know that as being a relatively new feature. Elements of transaction tracking started getting into the product in the CICS 4.3 range, I believe, but really it started to grow up at the last start of the version 4 and now into version 5. So by 5.1, 5.2, 5.3, and now 5.4, transaction tracking is just a phenomenal piece of infrastructure inside of CICS. But I use that word infrastructure to describe it because, and that's really what it is. What transaction tracking does is it focuses on tracking any and all related transactions within CICS. And it does that by creating a concept called a transaction group. And in fact, as we'll see in the demonstrations, there's now an item that is generated for a transaction group called, suitably enough, a transaction group ID. But with just transaction tracking, it's really important to understand that with the framework that IBM has provided, which handles everything perfectly within CICS, there is little or no support for correlating what transaction tracking is doing with the outside world. So, for example, there's no way to associate information received with an HTTP request with a transaction group. Likewise, there's no way to support data that may have come in via CTG or an EXCI request with a transaction group. And that's really, again, the essence of what we're trying to solve. We want to take an item, an artifact, a token, a bit of correlation data from the outside world, bring it into the CICS environment, associate it with a transaction group, so that by the time SMF records are created and data flows down to Splunk, that Splunk has a complete end-to-end view, so that it can correlate that this particular correlation ID goes with this set of transactions under a given group, and now by virtue of that seemingly simple correlation, now we can gain true end-to-end visibility. So the thing to remember is transaction tracking is certainly necessary. It's just not all you need to be able to do this. Now, our initial version of HTAC focuses on HTTP and CTG. We're doing some work with some other transports into CICS right now, and we would be very interested in hearing from you or any customers about other transports into CICS that you would like for us to consider. But again, right now the first one, and what I'll demonstrate today, is HTTP. CTG is also fully supported. We've also focused on Splunk as the SIEM platform. There certainly are others, but given Splunk's adoption within our particular customer base of large, complex, domestic and multinational corporations, we chose to focus on Splunk. We also, I'm going to talk in a minute about how we get data out of the mainframe. Now, we provide with HTAC what we refer to as a emitter, and the emitter's job is to move this information out of CICS into Splunk. The emitter that we wrote is really great for rapid POC projects, for testing. It's easy to install and implement. However, for highly scaled organizations where you might have a dozen, let's say 100 regions or more, we are a real advocate of SyncSort IronStream for those sorts of environments. So we're a business partner with SyncSort, and we collaborate together around these topics. So I'll be demonstrating the use of our emitter, but please note that everything you're seeing is fully compatible with SyncSort IronStream. Let me give you a little more technical detail. Obviously, being a technical guy myself, I just can't help but draw drawings. So here we are kind of in a typical network where we have lots of end devices over here coming through various networks that may include load balancers, routers, whatever. And in fact, a lot of times in many organizations, it's right here at the load balancer where a unique token is often added to the HTTP request that identifies the end user and their request coming in. Then, of course, often that request is going to go to an HTTP server on some sort of a non-mainframe app server. There's some program that handles that request and controls the user interface. And then if it needs to rely upon the mainframe for back-end activity, data and or business logic, it will use some sort of a connector. It might use CTG to send the request over to the mainframe, or it might use HTTP. There's a growing group of organizations who are doing just that. Just for technical completeness, I also show that obviously you can have a program running under ZOS communicating to CICS across EXCI. Regardless of the way in which your request comes into the mainframe, you're going to be running some sort of a transaction to start with. We'll call it the initial transaction. But the way CICS transactions often work is they have kind of parent-child relationships or dependencies in order to do their thing. So, for example, a transaction running in region A might communicate or start a transaction running in region B, which might cause a transaction, a mirror transaction in region C to be invoked. So there is some sort of, usually a relationship, a transaction pattern that can occur. Now, let's add to this just a little bit. I wanted to put this little blue bubble up here just to let you know where HTAC lives and what he does. So HTAC extracts the correlation data that has been sent in from either the end client, the network balancer, or maybe your server programs. We extract that correlation data and we use it to enrich the transaction tracking origin data. Then CICS Transaction Tracking will do its thing. It will propagate that enriched origin data across all transactions in the transaction group. Then using some sort of a form, it could be as simple as you creating your own mechanism to send SMF records down to Splunk or an SIEM platform, or using our emitter that comes with HTAC, or using IronStream, some way that mainframe is going to publish the activity records, and those activity records will include that correlation data down to Splunk. Similarly, over here on the non-mainframe side, or maybe even in the network side, those components are going to contribute their activity records, which will also include that user correlation data. Now, once we have the user correlation data associated with the activity records outside the mainframe and with the activity records inside the mainframe, now we can make the connection. Now, a platform like Splunk can very easily say, okay, I can see the entire end-to-end flow of activity from client all the way through the mainframe and all the way back. And that's really the objective. Now again, just for completeness, let's be clear. We, HTAC, don't generate the request correlation data. It is generated by something else. And we don't even care what it is. To us, it is just an opaque set of bytes. If you're using something like App Dynamics or various CA products in your middle tier or in your networking component, they have particular standards that they like to use for how you create and convey request correlation data. That's fine by us. We don't care. All we care about is the fact that whatever the request correlation data is, if it's coming in across HTTP, it's conveyed via an HTTP header. If it's going to come in across CTG, it needs to either be in the COM area or probably more preferably a container in the channel, and same way with EXCI. So that's kind of the broad overview of all the components in order to create end-to-end visibility and correlation. I also mentioned IronStream. Everything with HTAC works identically as I'm describing today. The only difference is that IronStream would then be that component that takes your SMF record feed and then drive it out to Splunk to be able to get the data. The data is the same. IronStream just acts as what we would call the collector and emitter functions to get it down to Splunk. Now it's time for me to hold my breath and do a bit of a demo. The first thing I'd like to do is just come over here to a Splunk dashboard. If you've never seen Splunk, or whenever you log on to Splunk for the first time, you see something like this, and you're not quite sure what to do or where to go. So the best thing to do is let's just click that arrow and say we want to do some searching and reporting. And I don't really have a search. I'm just going to enter a star and say, show me everything that's out there. I don't even know, right? Okay, so yeah, let's see. There's some events out there. Now, I'm not going to get too hung up about what these events are or aren't, but what I am going to do is use a tool, Postman, to drive a simple request into the mainframe. Many people are familiar with Postman. If not, no big deal. All it is just a tool to be able to send HTTP requests, get back the response, and play games in doing that. So it's just simply going to send a request to the mainframe. HTAC is running on this mainframe, and all it's going to do is send a simple HostBridge request, and then I'm going to get back a HostBridge response. Before I do this, I'd like to clarify one thing. Obviously, many of you know that of HostBridge, we've been around. We have a variety of products. We're most well known for our server-side JavaScript engine and our ability to use that engine to orchestrate transactions running within the mainframe. But I want to be clear that you do not have to use HostBridge or any other product from HostBridge if you would like to use HTAC. HTAC will work with anything. It will work with your homegrown COBOL programs that you're communicating to across HTTP and SOAP messages. It can be used with your COBOL programs that are being invoked across CTG. You don't have to be using the HostBridge base product or the HostBridge JavaScript engine. It just so happens I'm going to demonstrate it using that, but as far as you're concerned, this request could be going to any other program, not written by yourself. So the first thing I'm going to do is I'm just going to send that request in. I'm going to look at the timestamp. It happened right about 11:29. And I'm going to go over to Splunk, and I'm going to do a refresh, and I'm going to see what Splunk has over here. Now, you'll notice that, sure enough, at 11:29, there were 3 events that came in. Now, when I ran that request, a number of different things happened. Actually, 3 transactions occurred. You can kind of see this is the information that HTAC sent down to Splunk for this first transaction called HWBA. You'll notice that this is everything in the standard CICS monitor record, which also means it's everything that you would see in an SMF type 110 for a transaction. I went ahead and turned on all of the options so that you can see everything that's going on here. I'm not suggesting that you would do this maybe in a production environment, but these are all of the actual metrics that relate to the transaction. I can see the application information. I can see all the detail. I can see network, unit of work. I can see everything. The environment, let's see a little bit there. Came from the origin information is always kind of interesting. Came from 192.168.10.41. That happens to be my IP address running on the inside of HostBridge network, and you can see various other things. All of these data, this is just standard CICS monitor data and SMF 110 data that has been expressed as an event going down to Splunk. I mentioned that CICS ran all these under a common transaction ID because they were related. And you see that the transaction group ID is in fact identical. If I had any doubt about that, I could have Splunk confirm that. And sure enough, there are only 3 transactions with that transaction group ID. So that hopefully gives you just a little bit of a feel for how data can be expressed or viewed in Splunk, at least in the very raw format. I'd like to draw your attention to this field up here called OUserCore. This is a defined field in the DFH monitor record and in the corresponding SMF110s that is used to convey user correlation data. Of course, the problem is, how in the world do you get something in that field? And that's exactly what HTAC solves. So let's go back over here to Postman, and I'm going to show you how this works. I'm going to send in this exact same request with an X-request ID header, and let's say that, I want to say that it's Rus-11:33, at least in Central Standard Time Zone. So that's going to be my request ID for this next request. So I'm going to send that in. Request runs exactly as you would have expected. Let's go back over to Splunk. Let me refresh over here. Okay, there we are. So you'll notice that I have three entries down into Splunk at the right timestamp. Let's open up the event, and sure enough, now in the O-user core field, I have that data, 11:33 CST. Now, what we just did there was give you that's like the tip of the iceberg view to let you see how we have now created correlation. We took a data element from outside the mainframe, passed it into the mainframe, treated that in a very special way under the covers of CICS, such that it would be permanently associated with all transactions inside the transaction group. So now we have this association right here, and now with that association in the Splunk database, we can start to do some fun things. Now, when it really comes down to using Splunk, it's really fun to use this sort of a search view. But in reality, we tend to use more a dashboard view. And so I'm going to switch modes here. What you're seeing here is a demonstration application that James Alexander on our staff developed. Now, we have this debate going on inside of our company about, well, which is the best demo app? And we can never make up our mind. And so we decided, well, we'll just use all three. So a long time ago, IBM came out with a demo app called the Trader app. So you see that in the upper left-hand corner. Then they came out with a demo app called the eGUI application. You see that in the lower left. Then we thought we'd just throw in some direct DB2 queries. And then in the upper right, we actually have a little control board that lets us see kind of what's going on. Now, all we use this for is to generate some load, because I really don't want to use Postman and just kind of, click Postman for the next hour. So I'd really rather do something else. So let's go ahead and generate some load. Now, what this is doing is whenever I say I want to buy 3 shares of that company and buy 3 shares of that company, and I execute, what's happening is a request just went up to the mainframe to run a script. And that script actually did that work. Now, the nature of this application, or the nature of the demonstration, isn't so particular. As I said, it doesn't matter what the nature of your application is. We just happen to be using our JavaScript engine running under CICS to be able to do the demonstration, because it makes it really, really, really easy. But let me go over here to Splunk, and I'm going to go ahead and refresh it, because I ought to have a lot of new data there. And sure enough, I do. I've got lots of data. In fact, look here. I've got my client actually created a record that said at that particular time and date, it sent up a request, and he declared that the O-user core was that value right there. And then here's the first thing that probably happened on the mainframe, and sure enough, that user correlation data is there, all the way up to and including the response that came back from the mainframe, and it too has the user correlation. So this record, the response and the request record, which came from the client, obviously it really only knows about the user correlation, which it created. And then up on the mainframe, in our records, we know both. We know about the user correlator, and now we know about the tran group ID. So now once I know those things and I have some data, I can start to do some really interesting things. For example, I could come up here And I'm just going to copy this. And I'm going to come up here. I'm going to copy that. And you know, I could do searches using that string, but actually I think what would be more fun is, let me go over here to a Splunk dashboard. So we did a little Splunk work to create a dashboard item, and here's one. So what this is going to show me is everything that happened inside the mainframe associated with that user correlation token generated by the client. Okay, now we're getting there. Now what this is showing is that kind of a timeline. Now things are happening very fast at millisecond and microsecond speed, so that's why on the top line of the transaction timeline it's the same hour, minutes, and seconds all along. But what you can see here is that, okay, the first transaction that started was HBJS, and it ran on CICS, and then it started HBGP, which then runs on CICS. And then apparently, in order to run this transaction, it needed to go cross-region. So sure enough, here's a mirror transaction, and that mirror transaction existed for quite a while, relatively speaking. Then the first thing that he ran over in C was another HBGP transaction, and then he ran a number of TRAD transactions. I'm just guessing, you know, what does that look like, a dozen or so? And that just gives you, I created that to give you a general flow of what's going on. Then down here, we're using Splunk to be able to see, okay, tell me more about each of those. So down here, what we're showing is the actual transaction, the specific transaction of each one of these, as well as its transaction identifier. So if I had any question about the work, so I know that this user request caused all this to happen. So if I had any concern about, well, why in the world, how did transaction let's see, 10248 come to be? I know conclusively that, well, it was a transaction that was started as part of a request that came in from that user correlation data. Now, just to be cute, what we've done here, let me go ahead and generate a little more data. And let's go ahead over here and run one of that. Just to show you the way that you can integrate your client-facing applications, or maybe even your own internal applications with Splunk, we've created a link down here. Whenever we run Trader over here and run a script up on the mainframe and do something, this token will change. Well, this token is actually a link, so that's just a hyperlink that will now go over to Splunk. So in fact, when I did that Trader transaction just then, this is what happened. So regardless of whether this is a good model for you to use, whether knowing this would add value to your organization or not, that's not really the point. The point is that all of the data is now in Splunk, which allows us to be able to correlate the activities that happened on the client side with everything that's happening under the covers of CICS. One of the things that's kind of fun to do, I'll put it in automation mode and see if there we go. Now, with automation mode, all we're doing is just generating some load. And I want to generate some load so that I can come over here and demonstrate another dashboard that might be interesting for this situation. And we call it the scripts executed. So what we have here is kind of a high-level view of everything that's been going on. So in order to produce this very simplified view, we're using data both coming from the client side as well as coming down from the mainframe, augmented with the user correlation data from CICS. Now, I can refresh this, and since I'm running, I have that simulation running, these numbers are going up. But let's see, I really wanted to know a little bit more about Trader J. I can even click on that, and then a search will run, and I can see a little bit more as to what happened over the last hour. And you can see here's what's happening over here now. We're on the right side of the chart. And you can see not only the number of transactions that are being executed, but also the total duration. It looks like since we've been doing this test, the lowest duration was 151 milliseconds and the highest was 1.5 seconds. But you can do this across any of these. Now, Clearly, I wrote these scripts and these dashboards just for purposes of this demonstration for you. But the point is really that once we have down in Splunk sufficient data to be able to do these sorts of activities, then the options are virtually endless as to the kind of reporting, the kind of dashboards that you can build within your organization that allow you to gain a complete view from end to end. If you're a HostBridge customer, you know that we, like many ISVs, tend to license things on the basis of the size of your mainframe or the number of applications. We thought with a product like this, it would be interesting to take a whole different approach. So we're going to do it based upon volume, but only the volume of correlated transactions, because those are really where we've added value. And when we say a correlated transaction, let's imagine that you have today all sorts of CTG requests and HTTP requests coming in, and none of them have any request correlation data in them. So that when the HTAC exit fires up, it's going to look for that correlation data. It's going to very quickly determine there's nothing there, nothing for me to do, return control. Well, that costs you zero. So when we say a correlated transaction, that is a transaction that does in fact have a bit of correlation data in either that comes with the CTG request or with the HTTP request, where we can take that data and we can actually correlate it and add it to and enrich the CICS Transaction Tracking data structures, and then ultimately yield that information back to Splunk. So we are charging on the basis of the volume of correlated transactions. And so there's no charge. If you're doing less than 1,000 correlations per day, there's no charge. And our intent here is just we want people to download it, to install it, to get to learn from it, and just play with it. Once you get above 1,000, up to 100,000, okay, then there's going to be an annual license, and you can see the charges going up from there. So it is an annual license model, but it is purely based upon the number of correlated transactions, not your total transactions, and not the size of your mainframe.